A molecule essential to the origin of life has been detected in the protoplanetary disk of the Orion Nebula. Methyl carbocation is an unstable molecule that is the building block of more complex carbon-based compounds. According to scientists, it plays an important role in the formation of many other molecules that are fundamental to life on Earth. Thanks to the James Webb Space Telescope, JWST, a methyl carbocation has been detected in a young star system known as D203 to 506, which is located in the Orion Nebula, about 1,350 light-years from Earth. Carbon-based chemicals are the basis of all life, at least as we know it. They are of particular interest to astrobiologists who are trying to expand our understanding of how life on Earth originated and developed, and how and where it might possibly develop in other parts of the cosmos. Now, thanks to observations made with JWST, scientists have found a methyl carbocation in the protoplanetary disk surrounding a young star in the D203-506 system. Led by astronomer Olivier Bernet of the University of Toulouse in France. The team took a closer look at the Orion Nebula as captured by JWST's mid-infrared spectrometer. There, they discovered puzzling lines in the spectrum that are ultimately best explained by the presence of the methyl carbocation. Researchers have detected them in a disk of dust and gas that swirls around a young red dwarf, and protoplanetary disks of this type give birth to, among others, planetary stars. Planets. The Solar System was also born from such a protoplanetary disk. So studying the disks around other stars can help us understand exactly how our planetary system formed and how life originated here. While the methyl carbocation is not an essential ingredient for life, scientists believe it helps build more complex carbon molecules. And since life as we know it is based on carbon, finding this molecule in interstellar space has implications for our understanding of how life can originate and thrive in other parts of the galaxy. The results, published in the journal Nature, provide insights not only into the chemistry of fledgling planetary systems, but also into the physics of young stars. These objects emit a lot of ultraviolet (UV) light, and previously this radiation was expected to break such particles apart. The star in D203 to 506, as already mentioned, is a small red dwarf, and its system is bombarded with strong ultraviolet radiation from nearby hot, young, massive stars. Scientists believe that most planetary disks go through a period of such intense UV radiation because stars tend to form in groups that often contain massive stars that produce this type of radiation. UV radiation is normally expected to destroy complex organic molecules, so this finding may come as a surprise. However, the team predicts that UV radiation may actually provide the energy needed to form the methyl carbocation. Once formed, it promotes additional chemical reactions that led to more complex carbon molecules. Overall, the team notes that the particles they see in D203 to 506 are significantly different from particles found in typical protoplanetary disks. First of all, the researchers could not detect any traces of water. This clearly shows that ultraviolet radiation can completely change the chemistry of a protoplanetary disk. It may actually play a key role in the early chemical stages of life, Bernay explained. Questions remain about the role the methyl carbocation plays in interstellar chemistry. Greenhouse gas emissions are causing the stratosphere to shrink. The thickness of the stratosphere has decreased by 400 meters since the 1980s and will decrease by another kilometer by 2080. Scientists have determined greenhouse gas emissions are responsible for this. These changes may affect satellite operations, GPS navigation and radio communications. An international team of climate scientists has found evidence that man-made greenhouse gases have caused the stratosphere to contract. The findings, published in the journal Environmental Research Letters, show the profound impact humans have on the planet. The stratosphere extends from about 20 kilometers to 60 kilometers above the Earth's surface. Below that is the troposphere, a layer extending from the planet's surface to about 20 kilometers. The stratosphere, due to the ozone layer, plays an important role in absorbing harmful ultraviolet radiation. However, as recent measurements have shown, this layer is shrinking. Until now, the loss of stratospheric thickness has largely been attributed to the depletion of the ozone layer as a result of the widespread use of chlorofluorocarbons, CFCs, for many decades. However, the phasing out of CFCs has allowed the ozone layer to recover significantly over the past 20 years, alleviating concerns about permanent damage to the stratosphere. But new research reveals that the stratosphere continues to shrink even though CFC consumption has fallen and the ozone layer has recovered significantly, indicating that another factor must be driving this alarming trend. Previous studies have shown that the troposphere is thickening due to greenhouse gas emissions. This indicated a contraction of the stratosphere due to pressure from below, but the new study is the first to show this. In a new study, scientists sought to learn more about the impact of greenhouse gas emissions on the stratosphere. For this purpose, they obtained satellite data dating back to the 1980s. They added them to a computer model that also took into account chemical interactions in the atmosphere and the effects of the ozone layer. They also compared this data with climate models that take into account the increase in carbon dioxide emissions over this period. Such emissions cause the troposphere to heat up and expand, thus squeezing the stratosphere from below and compressing it. The models also showed that when carbon dioxide leaked into the stratosphere, it had a cooling effect. This drop in temperature forces the gases in this atmospheric layer to shrink in volume, leading to an even greater loss of the stratosphere. Calculations showed that since the 1980s, the stratosphere has shrunk by about 400 meters, which translates to about 1%. Its thickness. Further development of the models showed that the stratosphere would continue to thin as long as greenhouse gases were emitted into the atmosphere. Scientists suggest that the stratosphere could shrink by up to 1 kilometer over the next 60 years. The models also showed that changes in the ozone layer had little effect on stratospheric thinning. According to the scientists' data, the continuous shrinking of the stratosphere correlates well with the steadily increasing greenhouse gas emissions over the last 40 years, suggesting that our emissions are indeed responsible for this change. We found that the stratosphere has been shrinking by more than 100 meters per decade since 1980. We also proved that this is due to greenhouse gases, explained study author Juan Antonio Anel of the University of Vigo in Spain. In the most likely scenario of climate change, our planet's stratosphere could lose 4% of its energy. Its vertical extent, or about 1.3 kilometers by 2080, he added. The researchers note that it is still unclear what impact the shrinking stratosphere may have on the planet, but indicate that it could affect satellite trajectories and the way radio waves propagate. ultimately affecting GPS navigation. A billion-year-old fossil of one of the earliest multicellular organisms. In the Scottish Highlands, scientists have discovered a fossil of a microscopic organism that lived about 1 billion years ago. The find contains 2 different types of cells and may be the earliest multicellular organism discovered so far, the researchers say. A tiny organism that lived 1 billion years ago had 2 different types of cells. One of them formed the core of the organism, and the other constituted its outer skin. As scientists studying the fossil point out, it may be one of the first life forms built in this way. The finding suggests that animals evolved at least 1 billion years ago and may have occurred in freshwater lakes rather than the ocean. The study of an ancient organism dubbed Bicellum brachiaeri has been published in the journal Current Biology. The fossil, which may be the earliest multicellular organism known to us, was discovered by an international team of scientists led by researchers from the University of Sheffield in the UK and Boston College in the US. An ancient microorganism is providing scientists with new insight into the evolution of single-celled organisms into complex multicellular organisms. The fossil represents an organism that lies somewhere in between. The origins of complex multicellular organisms and the origin of animals are considered 2 of the most important events in the history of life on Earth. Our discovery sheds new light on both of them. We found a primitive spherical organism consisting of an array of 2 different types of cells, the first step towards a complex multicellular structure. This is something that has never been found in the fossil record before. The discovery of a new fossil suggests to us that the evolution of multicellular organisms took place at least 1 billion years ago, and that the early events that preceded animal evolution may have taken place in freshwater lakes rather than the ocean, said Charles Wellman of the University of Sheffield. Scientists have classified Bicellum brachiaeri as protists, simple eukaryotic organisms. The origins of complex multicellular organisms and the origin of animals are considered 2 of the most important events in the history of life on Earth. Our discovery sheds new light on both of them. We found a primitive spherical organism consisting of an array of 2 different types of cells, the first step towards a complex multicellular structure. This is something that has never been found in the fossil record before. The discovery of a new fossil suggests to us that the evolution of multicellular organisms took place at least 1 billion years ago, and that the early events that preceded animal evolution may have taken place in freshwater lakes rather than the ocean, said Charles Wellman of the University of Sheffield. Scientists have classified Bicellum brassieri as protists, simple eukaryotic organisms. The research team will now want to comb the area thoroughly in the hope of finding equally interesting fossils that could provide a better insight into the evolution of multicellular organisms. Scientists believe that these deposits may contain a wide range of microfossils documenting life in a non-marine environment 1 billion years ago. Scientists unpacked the mummy of Amenhotep I in an unusual way. All royal mummies found in the 19th and 20th centuries have long since been opened, with one exception. Egyptologists never dared to open the mummy of Pharaoh Amenhotep I, not because of some mythical curse, but because it is perfectly wrapped, beautifully decorated, and the face and neck are covered with an exquisite, realistic mask with colored stones. Researchers from Egypt, however, decided to learn the secrets of Amenhotep I thanks to the most modern technology. They used 3D quartz scans to digitally unwrap this royal mummy and examine its contents. Amenhotep's mummy has been opened for the first time in 3 millennia. The last time it happened was in the 11th century BC, more than 4 centuries after the original mummification and burial. The hieroglyphs describe how, years later, priests restored and reburied royal mummies from more ancient times to repair the damage done by grave robbers. The results of the study were published in the journal Frontiers in Medicine. The fact that the mummy of Amenhotep I has never been opened in modern times has given us a unique opportunity. We were able to examine not only what the mummification looked like originally, but also how the mummy was treated during the ancient restoration and reburial, says the main author of the research. Professor Sahar Salim, a radiologist at Cairo University's Faculty of Medicine. Thanks to digital technologies, we were able to unpack the mummy and learn about its layers, including the face mask, bandages used and the remains themselves. We were able to examine this well-behaved pharaoh in detail. It's an unprecedented situation, Salim said. We found out that at the time of death Amenhotep I was about 35 years old. He was about 169 centimeters tall, circumcised and had good teeth. 30 amulets and a unique gold-beaded belt were found in the bandages. It seems that Amenhotep I physically resembled his father. He had a narrow chin, a small nose, curly hair and gently protruding upper teeth, describes Professor Salim. We found no wounds or disfigurement from disease that could indicate cause of death. However, we discovered numerous injuries that occurred after death. They were probably created as a result of grave robbers. The pharaoh's insides were removed by the first mummifiers, who, however, left the brain and heart, the researcher explains. The mummy was discovered in 1881 among other reburied royal mummies, at the archaeological site of Deir el-Bahari in southern Egypt. Amenhotep's name means, Amen is pleased. Amenhotep I was the second Egyptian pharaoh of the 18th dynasty. He succeeded his father Ahmose I, who expelled the invading Hyksos and unified Egypt. His reign lasted from about 1525 to 1504 BCE. It was a kind of golden age. The state was prosperous and safe. There were numerous construction works and successful war expeditions to Libya and northern Sudan. After his death, Amenhotep I and his mother Ahmose Nefertari were worshipped as gods. Professor Salim and Egyptologist Dr. Zahi Horus had previously speculated that the main intention of the 11th century BC restorers was the reuse of royal tomb furnishings for later pharaohs. However, now researchers have disproved their own theory. We show that, at least in the case of Amenhotep I, the priests of the 21st dynasty painstakingly repaired the damage inflicted by the looters and restored the mummy to its former glory, keeping the fine jewelry and amulets in place, says Professor Salim. Horus and Salim studied more than 40 royal mummies from the New Kingdom period as part of a project that has been running since 2005. 22 royal mummies, including those of Amenhotep I, were moved in April 2021 to a new museum in Cairo. Our work proves that CORT imaging can be beneficially used in the anthropological and archaeological study of mummies from different cultures and civilizations, conclude Salim and Horus.